This is the reference booklet video for segment properties. Before we review segment properties, you need to be familiar with these algebraic properties: the distributive property, the addition property, the cross multiplication property, the multiplication property, the division property, both the transitive and the substitution property, the communicative and the subtraction property. You should also know the difference of the addition, subtraction, multiplication, division of real numbers, or working on one side of the equal sign, versus all of these with property here and here, all, not the transitive, subtraction property, all involve working on both sides. Now, properties of segments include this. Segments can be symmetric, which means if you have AB, the segment, it's congruent, going the other way, to BA. That's called symmetric. Reflexive. Let's say if I draw in a segment right down the middle of this triangle, and now I've created two triangles, so that segment is exactly back to back with two separate triangles. We would write PQ is congruent to PQ. It's congruent to itself. Another example would be overlapping triangles. Let me give you an example here. Here is the blue triangle. Trace with me if you can. And here is a green triangle. Notice they overlap. Let's say those two triangles overlap at the segment HI. We would say it's congruent to itself. So in this case, we would say HI is congruent to HI. Again, reflexive. Transitive. Transitive. Let's say I have the points D, O, G, S. D, O, G, S. And let's say in this I knew that the segment DO and OG were congruent. And let's say I also knew that OG was congruent to GS. In this case, you can see we overlap at the segment OG. So we can transfer the congruency from DO to GS. Therefore, we can do like this. Transfer congruency and say that DO, the first segment, must therefore be congruent to GS. That's called transitive. We transfer congruency. Segments can be added. Let's say I have M, I, T. I can say the distance of M to I plus the distance of I to T equals the longer distance M to T. Little segments add up to bigger segments. If you were to use this in an equation, we'd end up with something like this. Something plus something equals a larger something. Last property is that segments can have midpoints. Let's say Q here is a midpoint of DE. You'd have to have hatch marks. So in this case, the distance of D to Q would be equal to Q to E. If you were to have a midpoint, most likely you would be using an equation in which something is equal to something. So check and make sure you have all the information written down.